Engines define how humans move, build, and explore. For over a century, the V8 engine has been a symbol of power and performance. Its deep rhythmic growl became the heartbeat of sports cars and muscle machines, but now, electricity is rewriting that story. Imagine a V8 that runs not on gasoline, but on magnetism. No explosions, no exhaust, only pure motion. This video explores how an electric V8 engine works, how it mimics the behavior of a real one, and what it reveals about the future of transportation as the world moves away from combustion and toward clean electric energy. A gasoline-based V8 engine is a mechanical masterpiece built around fire and pressure. Inside it are 8 cylinders arranged in a V shape. Each cylinder holds a piston that moves up and down. Air and fuel mix inside each cylinder, then a spark ignites this mixture. The explosion releases hot gases that expand, pushing the piston downward. That downward push turns the crankshaft, a rotating rod that converts the piston's linear motion into circular motion. Through gears and shafts, this spinning energy reaches the car's wheels, producing forward motion. Each piston in a V8 fires one after another, not all at once. This sequence keeps the engine balanced and smooth. The timing between each firing event is carefully designed to reduce vibration and deliver continuous torque. The more pistons firing in sequence, the steadier the motion feels. But, this design has limits. Combustion engines waste much of their energy as heat. They need cooling systems, lubricants, and, hundreds of moving parts that all create friction. Every piston stroke involves tiny explosions, constant wear, and mechanical losses. Still, the V8 remains iconic. Not for its efficiency, but for its sound and power. Its growl became a signature of human engineering strength, a rhythm created by fire and steel. Now imagine a V8 engine that uses no fuel at all. Instead of explosions, it actually uses magnetism. This electric V8 replaces the piston and cylinder design with solenoids. Those are coils of wire that act as electromagnets. Inside each coil is a small permanent magnet that slides back and forth. When an electric current flows through a coil, it creates a magnetic field. This field attracts or repels the magnet inside. The motion looks identical to a piston stroke. When the current stops, the magnet moves back, ready for the next cycle. LEDs show when each coil is active, flashing in rhythm like firing pistons. All 8 solenoids connect to a shared crankshaft. As the magnets move up and down, they turn this crankshaft exactly like pistons would in a combustion engine. The result is mesmerizing. 8 magnetic pistons firing in perfect sequence, but without noise or smoke. Sensors inside the system detect when the magnet moves back into position. They automatically switch the current on or off at the precise time. The timing loop repeats dozens of times per second, creating a realistic piston motion powered entirely by electricity. The result looks mechanical, but runs on pure electromagnetism, motion born from invisible forces instead of burning fuel. In traditional engines, the firing order defines personality. It determines how power pulses travel through the crankshaft and how sound waves form in the exhaust. No 2 pistons fire simultaneously in a proper combustion sequence. That spacing creates rhythm and harmony inside the engine block. In a cross-plane V8, the left and right cylinder banks fire unevenly. This uneven timing produces the deep burble that defines American muscle cars like the Mustang or Camaro. However, it also requires heavy counterweights to balance the irregular firing pattern. A flat-plane V8, used in many European performance cars, fires in an alternating left-right pattern. This even timing gives it a higher pitch, smoother vibration, and quicker throttle response. The engine can rev faster because it is lighter and better balanced. The electric V8, however, follows another logic. It can fire any combination of coils at any time. 2 pistons can move together without consequence because there are no explosions to control or balance. The firing order is defined by software, not mechanical design. Although it moves like a combustion engine, it sounds almost silent. The unique growl of a V8 doesn't come from motion itself. It comes from burning gases and resonating exhaust pipes, a sound that electricity does not create naturally. Now first, like always, be sure to hit the like button down below. It helps us out tremendously with the reach of this video. Thank you. A piston engine must convert one type of motion into another. It turns the up and down movement into rotation through a crankshaft. Each conversion step wastes energy. Heat, vibration, and friction all reduce efficiency. Electric motors skip that process entirely. They produce rotation from the start. Instead of pistons, they use magnetic fields that spin a rotor continuously. One of the simplest demonstrations of this is a homopolar motor, a battery, a magnet, and a wire that can spin endlessly due to the Lorentz force. This force acts perpendicular to both the magnetic field and the electric current, generating circular motion naturally. Electric motors also come in different types. Brushed motors use contact brushes that rub against a spinning part to control current flow. They work, but wear out over time. Brushless motors, which use alternating current, solve this by controlling the current electronically. Tesla's induction motor, for example, uses 3 alternating current phases that create a rotating magnetic field. The rotor follows that field without physical contact. The motion is smooth, efficient, and nearly maintenance-free. This is why electric vehicles don't need pistons, valves, or spark plugs. They rotate directly, simply, and quietly. Combustion engines rely on chemical reactions. Fuel burns, expands, and pushes pistons. But that same fire, well, it wastes most of its energy as heat and noise. Cooling systems, oil pumps, and exhaust systems all consume extra power just to keep the engine alive. Electric motors, in contrast, convert electrical energy directly into mechanical work. Over 90% of input energy turns into motion. There's little heat, no exhaust, and almost no vibration. That's why electric cars accelerate faster. Power goes straight to the wheels with no mechanical losses. The electric V8 model shows engineers can replicate motion using only magnetism. Still, this design is valuable for learning. It visually bridges the past and the future, showing how old mechanical systems can inspire new electrical ones. It proves that what once required explosions and moving metal can now be achieved through controlled magnetic forces. The electric V8 is not a replacement for the real thing, but a vivid teaching tool for the next generation of engineers. Even with all its efficiency, something about electric motors feels different. The emotional element, the sound, is missing. The V8's deep rumble connects people to motion in a visceral way. It vibrates through the car's frame, resonates in the chest, and signals raw power. Electric engines are nearly silent. Some enjoy the quiet hum, but others feel that silence removes part of the driving experience. For many, the sound of an engine represents personality, not just function. It's the rhythm of controlled chaos, metal, air, and fire dancing together. Automakers have started experimenting with artificial engine sounds. Some high-end electric vehicles generate synthetic noises that change with speed or throttle input. The electric V8 prototype reminds viewers of this cultural shift. It looks like an engine, moves like one, but operates without a single roar. Watching it work in silence feels both futuristic and nostalgic, as if two worlds overlap. Perhaps in the future, engineers will design new kinds of electric voices for cars, sounds that express energy differently. The growl of combustion may fade, but a new acoustic identity for motion will rise in its place. The electric V8 engine, really blends mechanical art with electrical precision. It copies the timings, rhythm and shape of classic combustion, while removing heat, waste, and pollution. Using magnetic forces to move pistons and turn a crankshaft, it shows honestly how motion can exist without fire. This experiment captures both history and innovation, the beauty of old mechanics powered by the science